Hey again, friends. All right, today's lesson is going to be on comparing fractions. Today's date is April the 22nd, and your IXL assignment today is going to be P18. So, just like yesterday, we're going to be comparing fractions, but today we're going to be using math to make those comparisons possible versus just relying on a model, because not always is a model going to be there for us. We have to have the tools ready to roll in ways of being able to solve without that picture. So we need to make sure that we've got the mathematical steps down to be able to do this. So a rule to remember, same as yesterday. You cannot truly compare a fraction without having equal denominators. So if you do not have the same size pieces, you cannot truly share which one you think is larger or not without some kind of a proof or without some kind of a background. So we'll take a look at this first one here. Which fraction is greater? 1/4 in comparison to 3/4. My thought process should be, first, is my denominator equal, or my size of my parts equal? Fourths and fourths. Well, yes, they are. So if it's not equal, I'll have to use some math to solve. But if fourths are equal to fourths, I just pay attention to which numerator is closer to all four pieces. Would I rather have one of the four pieces or three of the four pieces? Well, obviously, 3/4 is larger than 1/4. Easy peasy when I've got the same denominator. But I'm not always going to have that. My next question here asks, which fraction is greater? 2/3 in comparison to 4/5. Is my denominator equal? No, it is not. So what do I have to do? I have to solve it out. I actually have to prove how this works. I have taught you this school year 2 different ways to be able to compare fractions with math, and I'm going to do one review problem on both, okay? You obviously can choose which one works better for you. The first way is a little bit more heavy on your multiplication facts. The other way is just heavy on how you multiply numbers together, okay? So one way that you can compare 2 fractions with an unequal or dislike denominator is by listing out the multiples of each denominator until we find a match, for finding my least common multiple, okay? So essentially here, I'm going to list out the multiples or the jobs of each of these numbers. Well, the jobs or the multiples of 3 are the following: 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and I can keep on going and keep on going. I'm going to list out my jobs of 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, so on and so forth. Now, my eyes are going to do the work here of scanning to look for a number that matches in both lists, okay? 3, 6, 9, 12, 15, 18, 21, 5, 10, 15. I see a match here of 15, so I circle it, 15 and 15. Now, you're probably thinking to yourself, Mr. Hogan, I'm also seeing 30 is a match here down the road. But we want to keep the math easy here, and I want to keep it to my least common multiple, the first multiple that both of these numbers have in common, which is 15. So here's what I do. I want to count and mark how many times I have to multiply 3 to get 15, and how many times I have to multiply 5 to get 15. Well, 3 is multiplied 1, 2, 3, 4, 5. And I like to put my little multiplier number kind of in a box here so I can remember how many times I multiplied it. 5. I have to multiply 5, 1, 2, 3 times in order to get 15. My last step to get a common denominator between these 2 fractions is to multiply the fraction by the multiples order. So how many times did I have to multiply 3 to get 15? Well, I had to multiply it 5 times. My rule of whatever I do to the top, I must do to the bottom applies here. So 3 times 5 and 2 times 5. 2 times 5 is 10. 3 times 5 is 15. I'm going to put kind of a circle around that because that's important. I'm going to come back to it later. Now let's look at 4/5. I still can't compare 15 and fifths together because my denominator is not the same. But how many times did I have to multiply 5 to get 15? Well, I look at my list. 1, 2, 3 times. Multiply the top and the bottom by that number. 4 times 3 is 12. 5 times 3 is 15. Well, I look here at the very end. Which is larger, 10 of the 15 pieces or 12 of the 15 pieces? 12 is just a little bit closer to 15, which tells me at the end of the day that 2/3 is less than 4/5. 2/3 is less than 4/5. So in this situation, I listed out my multiples, found my first match, and multiplied that denominator by how many times it had to be multiplied to get that match, my least common multiple. Now, this is one way to solve it. The other way to solve it is the method with giving the problem wings, which looks very similar to the work that we did here, but this can save us some time in the long run. Your fractions will not always be their most simplified versions, but you can get an answer for it. So looking here, which fraction is greater? 1/2 or 4/6? Is my denominator equal? No, it is not. So if not, I need to solve. I'm going to give this problem its wings. And here's how I do that. I multiply each fraction by the other's denominator. I'm going to multiply the fraction by the other's denominator. Make sure you give yourself some space here. This might start looking familiar once I do this. Set up both fractions to get multiplied. My instruction tells me to multiply each fraction by the other's denominator. So I'm going to multiply 1/2 by the 6ths from this fraction. I'm going to draw an arrow to bring this 6 over here. Whatever I do to the bottom, I must do to the top. 6 times 1 is 6. 6 times 2 is 12. 6/12 is my new fraction to look at, but I can't compare 12ths to 6ths, so I have to finish out my whole problem. I multiplied halves by 6ths. Now I'm going to multiply the 6ths by the halves. Multiply the bottom by 2, 2 coming from here. Multiply the top by 2. 4 times 2 is 8. 6 times 2 is 12. My denominators are officially equal with 12ths, and now I take a look at my final piece here. Which is greater, 6 of the 12 or 8 of the 12? Well, obviously 8/12 is larger. So at the end of the day, the answer to my question, 1/2 in comparison to 4/6, 1/2 is less than 4/6. 4/6 is my greater amount. 2 ways: multiply each other by their opposite denominator, or create a list of your multiples and find your first match. Today, friends, you'll be working on P18 on IXL. You'll do great.